In lesson 1.2, we're talking about set operations. So the first operation is complement, which is another word for saying not. So not what you want. So given a set A and a universal set U, the set of all elements U that does not belong in A is called the complement of the set. So the elements of the universal set that do not belong in A. The complement of set A is written as A with an apostrophe after it, which we say A prime. So there's a little picture off to the side for you to look at where you've got a yellow box. The whole square is U, so that's the universal set. Then you've got a set A inside, that's the circle A. And then so if I ask for what's in set A, that's anything that's inside the circle. But if I want all of the numbers outside of the circle, I would ask for A prime, or the complement of A, which is why it's highlighted yellow. An example is if set A is all female students in this class, and U is the set of all students in this class, then A prime would be the set of all male students in the class, so the opposite of the female students. All right, example 1, you're given this universal set, and this set A and this set B, and they want you to find the complement of A, B, and U. So let's look for a complement of A. And we're going to always compare A to the universal set. So if I look at the universal set, 1 is in A, 2 is in A, 3 is not. So 3 is part of the complement. 4 is in A, 5 is in A, 6 is not. 7 is in A, and then 8, 9, 10, and 11 are not. So those are part of A's complement. So those are the elements that are in U, but not in A. They're in U, but they're not in A. So for B, you're going to do the same thing. You're going to list all the numbers that are in U, but not in B. So we can see 1 is not in B, 3 is not, 6 is not, 8 is not, and 10 is not. Then if you look at U, if the universe has all these numbers, then what's not in those numbers would just be an empty set. So the empty set is, anytime you're asking for the complement of the universal set, it's nothing. It's either in the universal set or it's not. Okay. Intersection. Given two sets A and B, the set of all elements belonging in both sets is called the intersection. So intersection is everything that's in A and everything that's in A and B. It has to be in A and B. They have to share them. They have to be in both. A and B is the words I wanted to use. So I've got set A has 1, 2, 3, or before I talk about that, I've got this Venn diagram, and you've got two circles. The A circle is all the elements that are in A. B circle is all the elements that are in B. And where they overlap, that is where they share numbers. And the intersection is the numbers that they share. If we look through these sets, we can see that they both share a 2, and they share a 4, and they share a 5, and they share a 7. So that means the intersection would be 2, 4, 5, 7. Those are the numbers that are in both A and B. Example 3, you're looking at set A, set B, and the universal set is all numbers 0 to 10, or the whole number 0 to 10. So you've got A intersection B. We're just comparing A and B. You see that they have 6 in common, and that's it. A intersection B complement, you might want to list out what B's complement would be. So you look at your universal set and you list all the numbers that are not in B. So that would be 1 and 3 and 5 and 7 and 9 and 10. Those are the numbers that are in U that are not in B. And then you want to find what do B's complement and A have in common. Well, it looks like they have 3 in common. They have 9 in common. And that would be it. So just 3 and 9. Now, if you get to a problem where they have nothing in common, then the sets are said to be disjoint. So they have no elements in common if they are disjoint. And then here is a picture of what that Venn diagram would look like, where you've got set A has numbers 1, 2, 3, 4, 5, 6. Set B has numbers 9, 8, 7, 8, 9, 10. And you see that they have none in common, so there's no reason for them to overlap. In terms of numbers, you can list the sets like that, and if you ask for the intersection, it would be an empty set because they have no numbers in common. All right, union. The set of all elements belonging to a set A to set B, or both sets, is called to be the union of the two sets, written as A union B. So this would be if it's an A or it's in B. As long as it's an A or in B, then it belongs to the union. So that if you're looking at a Venn diagram, you're highlighting the entire circle A and you're highlighting the entire circle B and this whatever they share. So it's just a collection of everything. So for A, you've got so we're gonna put them in order though. So A has a 1, both A and B have a 3. A has 5, B has 6, A has 7. They both have 9. A has 11, and B has 12. So it's what's in A, what's in B, or what's in both. And you just list all of them. So B union C B union C, these two, we see that C has a 1 and a 2. They both have a 3. C has a 4. C has a 5. And then B has 6, 9, 12. For the next one, you're going to want to find, so we already found that part up here. For C's complement, let's list out what is in C. So the universal set is 0 to 12, all the whole numbers 0 to 12. And C is 1, 2, 3, 4, 5. So C's complement would be 6, 7, 8, 9, 10, 11, 12. So then the and this one's the intersection. So you're going to take that set, and the intersection is what they have in common. So let's see, they have a 6 in common, a 7, a 9, an 11, and a 12. So then this final answer would be 6, 7, 9, 11, and 12. Okay. Example 8. So you're given a department store with applicants, and the universal set will be all of the applicants. The M set will be the set of male applicants. Set S will be the set of single applicants. Set E will be the set of employed applicants. So M intersection E, it has to be what they share, or not really what they share. So okay, I'll just write it. So the set, it's the set of all applicants. If I just said set of all applicants, that would be the universal set. But what I really want is, or I want to be more specific with just M and E. So it would be the set of all applicants that are male, who are both, they have to be both male and employed. So if it's intersection, they have to be both. You're going to use the word both and. It has to be in both, male and employed. For B, you are looking for the complement of M. So M is the set of male applicants, which means the complement would be the female applicants. So not male would mean female. And then S is the set of single applicants. And then we have union, which means it's either or. It's either you're female or you are single. All right, part C, you've got M complement and intersection S complement. So M complement is female, just like before. S complement would be the opposite of single or not single, so married. So then we've got the set of all applicants who are, and this is intersection. So that we're back to both and, who are both female and married. And then you've got M, set M, union, complement of set E. Set M is male. And then E's complement would be not employed. So unemployed. Since it's union, you're going to say either male or, let's write that better, or unemployed. All right, and then look at this last example. It's a you try. Pause the video and try this on your own. And then in a few seconds, I'm going to show you the answers. So pause right now. And here are the answers to the you try. So make sure you go through that. And if you got anything wrong, try to figure out what went wrong. All right, so that's lesson 1.2, and have a great day.